Hey guys, welcome back to a series of cracking the coding interview. Today we're going to solve a problem called remove duplicates. Feel free to pause the video just to read through what the problem is asking for, but I'm going to explain based on the description. Also keep in mind that this also happens to be a LeetCode problem. As you can see right here, feel free to pause the video just to read through and make sure the only differences in LeetCode we're asked to solve it for a sorted list, while in this book we're asked to solve it for an unsorted list. However, the algorithm we're going to develop today is going to work regardless of if the list is sorted or unsorted. Okay, first things first, again, read through the problem, but today we're going to solve it ignoring this. This says don't use a temporary buffer. Today we are going to use a temporary buffer. Also, this says to use 2 pointers. This hint right here, we're going to ignore this hint too, and we're just going to solve it using hint 1, a hash table. Technically a hash table is a buffer. Without further ado, let's get right to it. So the first thing I like to say is keep in mind that most people assume I like to consider my linked list to start with a head right here with a node that has a value of none. However, most people don't do this. Most people consider the head to be the first element that is not none. But today we're going to go my way because I'm the one who's teaching. So also let's add some indices to the elements of this linked list. Although a linked list typically doesn't use the concept of indices, it's going to make the explanation a lot easier. The first step we're going to do is we're going to create a buffer, which in this case is a set. Say I'm going to call him temp and set him to an empty set for now. So temp is set to an empty set, and then now we're going to iterate through this linked list using 2 elements, 2 variables, not pointers, 2 variables. The first one, I'm going to set him right here. I'm going to call him current. The second one, I'm going to set him right here. I'm going to call him previous. Then I'm going to go through this linked list. So in the first case, I'm going to say our first iteration of the linked list is going to be current is at index 0, because current is right here. Okay, because current is the guy who's going to drive our iteration through the linked list. When current is at index 0, what do we want to do? First is we're going to ask the question, is current the value of this current at that node, is he in our temp hash? Is he does he exist in this temp set? Obviously in this first example the temp is still empty, so no, he doesn't exist. So the answer is a no. In the case of a no, what do we want to do? First thing we're going to do is we're going to add him in there. So we're going to say temp.add value. So we're going to add that value in there. So let's go ahead and add him in there. So we're going to add 1 in there. So we've added that. Then what are we going to do next? We're going to take our previous guy and set him equal to our current guy. After that, in the end of this if statement, because this is obviously an if statement, if current in temp, in the end of this if statement, we're going to move our current variable. So we're going to say current is going to be equal to previous dot next. So let's go ahead and show what that looks like. First, we moved previous equal current. That's going to move previous, and then we move current to previous dot next. So this moves previous right here, and then since current is now previous dot next, current goes here. So now we're here. We'll go on to the next iteration. The next iteration is when current is at index 1. When current is at index 1, what do we want to do? We want to ask the exact same question. Okay, is current dot value in temp? So now what is current dot value? Current dot value is 1. Is 1 in temp? Yes, 1 is obviously there. We just added him because he was here. So the answer is yes. In the yes case, what do we do? That's simple. We're just gonna say previous dot next is gonna be equal to current next. Then outside of this if loop, we're gonna move our current as always. Current is going to be equal to previous dot next. Again, just like we did here outside of the if loop. So let's go ahead and see what this is going to do. So previous dot next equals current dot next. So previous dot next. So what that does is that breaks the next pointer of previous right here. So that breaks previous's next pointer and points him to whatever current dot next pointer is. So effectively that deletes this guy off because nobody's next pointer points to this guy. So that deletes it. Then next we're going to do current dot next is just previous dot next. So that's just going to move current to previous dot next. So that moves current right here. Current right here right now. Next iteration, current is now at index 2. Okay, what do we do at this index? Again, the exact same thing. We ask the question, is current.value in temp? In this case, current.value is 2. 2 is not in temp, so the answer is no. What do we do when the answer is no? The exact same thing we did previously where the answer is no. First, we add him, temp.add the value. So in that case, 2 is going to be added here. And then right after adding him, what do we do next? We're going to move our previous. We're going to say previous equals current. Outside of the if statement, we're going to move our current. Current is going to be previous dot next. Okay, so let's go ahead and see what that does. So previous now moves to where current is, and then current moves to previous dot next. So let's keep on trucking. Let's keep going forward. So now current is at index 3. what do we do again? The same thing we did before. We asked the question, is current.value in temp? In this case, we're asking, is 3 in temp? Answer is no. What do we do when the answer is no? Same thing we did in the past 2 cases where the answers were no. First thing we did was we added it, temp.add. We added the value there, so which is 3. And then what we did next is we moved previous to current, and then we moved current to previous.next. So let's go ahead and do that. So we're going to move previous to current, and then we're going to move current to previous.next. So now current is at index 4. What do we do now? Same thing, we ask the question, car.value in temp. Is he in temp? Is 3 in temp? The answer is yes. What do we do when the answer is yes? The same thing we did in the previous case where the answer was yes. We just simply said previous.next equals current.next, and then we moved current goes to previous.next. So let's go ahead and do that. So previous.next effectively breaks the next pointer of previous and moves him to the pointer of current.next. Effectively that breaks this and then moves him from right here to the next pointer of current. Then we move current to previous.next. So current moves right here to none. So this effectively breaks our loop because now current is at none, and then we return. So that's it for the algorithm. Let's go ahead and code up the solution. So just to give you a quick explanation, I've gone ahead and created the node class. Actually, let me change the name of this file to remove duplicates. So I've gone ahead and created my node class here. Also gone ahead and created my linked list class here. I also created the append function, which is the function that helps us to build all the elements in our linked list, and also the display function so we can see what the linked list looks like. And then finally, I have created a linked list of 0, 9 to blah blah blah. So pretty much this guy. So I want to work on him so I can get this guy. Okay, I want to remove the duplicates in this guy because once you remove duplicates, it gives us this guy. So we're gonna have to write our function and then call our function right here. Okay, because I'm displaying the original first and then I'm displaying the linked list after we've done our work with our function. So let's go ahead and create this function. I'm gonna call him remove duplicates. Standard boilerplate. And what is he gonna take in? Nothing. He just self. Again, self is just keyword for Python for any function or method in a class. So like I said, I'm gonna create our current and our previous. I'm gonna set our current equal to this element here, not the head. Our current starts off at this element, which is head.next. Okay, so current is going to be equal to self.head.next, while previous is going to start off being equal to self.head.value. Remember, because I want to set him equal to none, kind of like I explained. And once we do this, next step is we're going to go and create our temp, which is the set or the buffer where we're going to store the values we see. For now, we're going to make him an empty set. Let's move on. So while cur, because cur is what drives our iteration through the linked list. So while cur, what do? We're going to say if current.value is in temp. If he's in temp, what do we want to do? We're just going to move previous.next is going to be equal to current.next. Else, meaning he's not in there, he's not in our set, in our buffer. What do we want to do? We're just going to add him in there, and then we're going to move our previous. Our previous is going to move to our current, and then our current at the outside of this if statement, our current is going to move to previous.next, exactly how we described on the paper. Let's go ahead and run this and just make sure it works. Oh, I'm sorry, we forgot to call him, so we have to call him. So my list.remove duplicates, call him. So we forgot to call him, that's why it gave us the exact same. So boom, now you see all the duplicates from this first guy have been removed right here. Again, since this was a LeetCode problem, this is the exact same LeetCode solution right here. The only reason why we set previous equal to none, because LeetCode assumes, unlike me, LeetCode assumes the head node is right here, not right here. So that's the only difference. We didn't have to move our current node to head.next. Current node was already at head. So let's go ahead and run this and also see what we get. Submit this actually and see how we do. Okay, boom, submitted. We passed. Not too good in timing because again, this problem was more specific for a sorted linked list. There's an easier way to do it for sorted, while cracking the coding interview was for a non-sorted. So that's it for this video. I hope it was helpful. Stay tuned for the next one. We're going to solve this problem using a different method.